Hi, this is Dr. Shoikat Mahindar. Today we will discuss refraction of light. Already we have discussed in our first lecture of refraction what is refraction, background of this topic. It is under the unit 4 of light and its submodule is refraction of light 4.2. Learning objective to identify the angle of incidence, angle of refraction, also be able to relate the direction which light bends if given the relative speed of light in the two medium. Now, this that we have discussed back in background. We will go to the next part of the lecture. Now, this is we have discussed that is what is the incident ray, what is the refracted ray, what is the angle of incidence, what is the angle of refraction, definition of refraction, how light refracts, the analogy with the car, just a small recap, the car traveling an angle towards a muddy surface, one front wheel hits muddy surface and slows down, other wheels continue to move at a higher speed, causes the path to bend. This is the angle of incidence of light. This is the rarer surface, this is denser surface. When comes to this one, then the velocity of the light slows down and it moves towards the normal. This is what we have discussed for water to air. So in this case, velocity of light in water is less, air it is more. So when light comes from water to air, the velocity or speed of light increases, so it moves away from the normal. This is in analogy with the car moving from muddy surface to the normal surface. Then here its velocity is less when it is coming from at the interface of the muddy surface to the normal surface. The front wheels, its velocity increases, and the back wheels, its velocity is less. So what happens? Front wheel tries to move fast, and when it is trying to move fast, then what happens? It is deflecting away from the normal. Now, angle of refraction. The angle of refraction is measured relative to the normal. When moving from low to high refractive index, light bends towards the normal. This is air, this is low refractive index, glass it is high refractive index. So moving from lower refractive index to the higher refractive index, it bends towards the normal. So here theta I is the incidence angle and theta R is the refracted angle or angle of refraction. When moving from high to low refractive index, this one is glass, its refractive index is more, and this is air, its refractive index is less. When light coming from glass to air, then this is the incidence angle and this one move away from the normal, or light bends away from the normal. This is the incidence angle, this one is the refracted angle. So when light comes from glass to air, that means denser medium to the rarer medium, the refracted angle becomes more. or refracted angle increases. But when light comes from rarer medium to denser medium, then refracted angle decreases, that moves towards the normal, Now, with this term, we will come to natural phenomena, dispersion. The amount of refraction is different for each color. A single beam of white light can be split into rainbow of colors. Dispersion is a refraction of white light into separate wavelengths or colors. When white light falls on some prism, then the white light splits into its 7 constituent colors. We normally say it as VIBGYOR. VIBGYOR. V for violet, I for indigo, B for blue, G for green, Y for yellow, O for orange, R for red. So, splitting of white light into its 7 constituent colors is known as dispersion of light. This is what we can say for a diamond. Awesome picture. When light is falling onto it, it is just splitting around it the 7 colors. This is a real life example. What happens in case of rainbow? So, after a short rain interval, when there are particles in the atmosphere, so when sunlight is falling onto these water particles, then we can see the rainbow in the sky. This is how it is splitting. How rainbow forms? Suppose this is a water particle or water droplet. Sunlight, that is natural light or white light, is falling onto it. Then it is coming to this. So this is the normal direction. So the light splits into several colors, 7 colors. Light splits into 7 colors. What happens in case of prism? So from this water droplet, so light is reflected, again refraction, then it is coming to our eye. And this is the 7 distinct colors of the light that is formed from the water droplet during the formation of rainbow. This is a picture of the rainbow. What we observe here. This is the science why it is produced. Partial reflection and refraction. Suppose a part of light, suppose light, not a part of light, suppose light is falling on a glass plate. Some of the light rays will be reflected and some of the light will be refracted. So that means partially the light is reflected and partially the light is refracted. Refraction is often accompanied by reflection. some of the light hitting the surface of a body of water reflects and some refracts. Example, pond water, reflection sky, and refraction fish through water. Look, this is the pond water. Now, we can see here this bluish part. This is the sky. This is the sky. That means this is the image of the sky that you are getting due to the reflection in water. Again, suppose there is a tree, its branches, this is due to the reflection. We are seeing the branches. Another tree, its branches are here, leaves and branches are here. This is the reflection. But the fish that are here, we are viewing it due to the diffraction. That means light is coming from denser medium to the rarer medium. Denser medium to the rarer medium. This is due to the refraction. It looks like the fish is just moving upward. That means its apparent depth is less than its real depth. So this is the very good example of reflection and refraction at same time. So water that is acting as a good reflector or partial reflector, similarly the water is also acting as a refractor when we are getting the views of the fish from the water surface. And here we are due to the reflection we are getting the images of the sky, blue sky, green trees or green leaves of the green trees, branches of the trees, etc. Partial reflection and refraction. This is a very good picture. That means this is the sky. Sunlight is falling onto this one. This is the color, bluish color of the sky we are getting here at the water. Now, when light is falling, the surface between the water and air, then some part of light is reflected and some part of light is refracted. Ray diagrams can show both reflected and refracted light rays. Angle of refraction R can be calculated from Snell's law. We will explain it on later slides. Here I is the angle of incidence and this light is reflected from the surface. This is following the laws of reflection. So I is equal to the small r. Small r is the angle of the reflection. So any ray of light that leaving the medium, both reflected and refracted, are known as emergent ray. From this surface, this one is the emergent ray, and from this surface, this one is the emergent ray. So this is the diagrammatic representation of partial reflection and partial refraction. That means some part of light will be reflected and some part of light will be refracted. This light will follow the laws of reflection and this light will follow the laws of refraction. Large incident angle of light entering water results in nearly all the light reflecting. As the angle of incidence gets smaller, more the light refracts and less reflects. Look, suppose this is the object in water, inside the water. So when the incidence, if we draw the normal, when the incidence angle is more, the maximum light will be reflected. When incidence angle becomes narrower with the normal, then the light starts reflecting as well as the refracting. As we come close, this one is refracting and reflection becomes less. Here there is no reflection. It is passing to the normal. Again, it is changing, direction is changing, and this. So most reflecting when the large angle of incidence, then the reflection will be maximum. Most refracting when the small angle of incidence, when the angle of incidence is very small. Here again this is most reflecting. Why? The angle of incidence is large. This is a large angle of incidence. That means if the incidence angle increases, then there is a chance of only reflection. But when it becomes small, that means narrower to the normal, then refraction will occur, the small chance of or probability of getting reflection or getting reflected light. This is the diagrammatic representation you can understand from this one. Now another example of partial reflection and refraction, that is sunglasses. Silver two-way mirrors, plastic or glass, with special coating that reflects most light but still allows some to be refracted, results in a mirrored surface that you can see through but others can't. So when you are wearing the sunglass, so these glass plates, these are plastic glass or there is some special coating. So what will happen? The sunlight that is coming from outside, it will be reflected. Maximum of sunlight will be reflected from this coated glass plate or plastics. So the illuminated rays will come to our eye. So this will give us a smoothing experience. Again, anybody from outside who wants to view my eyes, then there is a chance to view my eyes is very small, because it is reflecting. It is reflecting partially, that is maximum reflection will occur here. That means he cannot find my eyes from outside, but I can find this person. I can find this person due to the partial refraction, So this is why we are using sunglass to smooth the glare of the sunlight, and we are using these sunglasses. One very good example of partial refraction is, don't miss a second, an architectural artwork by Monica Bonvicini in December 2003, installed at a construction site across from the London State Britain's Museum. A public toilet enclosed with reflective glass walls that allow the user to see out but prevent those outside from seeing in. This is the public toilet. The person inside the toilet, he or she can see outside, but anybody outside cannot see inside the toilet. That means this is the person inside. He or she can see due to the refraction of light, but the person outside, he cannot see because the total light is reflected from the outside walls of the toilet. So this is a very good example, and it is publicly placed at Britain, a public toilet enclosed by reflective glass walls. Let us recall some data. The speed of light is 3 into 10 to the power 8 meter per second. That means 300 million meter per second. That means 300,000 kilometer per second. This is equal to, just think, 1.08 into 10 to the power 11 kilometer per hour. Imagine 108 billion kilometer per hour. This is the velocity of light. However, it is impossible for light to move at this speed when particles get in the way. Suppose it is moving through the glass plate or moving through some transparent media, its velocity decreases. Then it is impossible to move with the speed of 3 into 10 to the power 8 meter per second. Speed of light changes depending on the medium. Already we have discussed this. Few data that we have shared. This is here again. Speed of light in a vacuum is 3 into 10 to the power 8 meter per second. Speed of light in water is 2 into 2.26 10 to the power 8 meter per second. Speed of light in acrylic 1.78 10 to the power 8 meter per second. These are a few data, many data are there. Index of refraction. Index of refraction, it is a ratio of speed of light in vacuum to the speed of light in medium. The amount by which a transparent medium decreases the speed of light. This is the index of refraction. Already I have told, a ratio of the speed of light in a vacuum compared to the speed of light in a medium. This is index of refraction. Speed of light in vacuum by speed of light in medium. So we will represent as N as refractive index is equal to C. C is the velocity of light or speed of light in vacuum is a constant. It is equal to 3 into 10 to the power 8 meter per second. And V is the speed of light in the medium. It varies medium to medium. For water it is 2.26 10 to the power 8 meter per second. For acrylic it is 1.76 10 to the power 8 meter per second. So this is, both are the velocity, meter per second. This is also velocity, meter per second. So units will cancel out. So refractive index does not have any units. Refractive index does not have any index.